Hi, everyone. I'm Ashley McManus, Senior Director of Global Marketing at SmartEye. Welcome to the Human Centric AI podcast, where each episode we feature thought leaders doing cutting edge work in the AI space. A little about us. SmartEye is the global leader in human insight AI, technology that understands a sustainable future. Today, our technology is embedded in next generation vehicles, leading the way towards human centric mobility through driver monitoring systems and interior sensing solutions. Our research instruments offer unparalleled insights into automotive, aviation, assistive technology, behavioral science, and many more fields. Today's episode features Senior Neuroscience Product Specialist at iMotions, Nam Nguyen. With over 15 years of experience shaping cutting-edge research across diverse industries, Nam's background encompasses everything from military and healthcare technologies, automotive UX, game design, and academic research. His expertise is matched only by his passion for sensors and technology. Currently advising research programs at iMotions, he brings cognitive neuroscience methodology to the forefront, backed by a history of rigorous scientific work and multiple peer-reviewed publications. Nam and I talked about aviation and how cutting-edge technology like eye tracking and biometrics are revolutionizing the aviation industry. Having gained insights from pilots and exploring applications in flight safety, training, and more over the years, from SmartEye Pro eye tracking to emotion analysis, we covered how iMotions enhances aviation tasks, monitors human-machine interaction, and ensures pilot readiness in the face of automation. Join us as we gain insights into the intersections of neuroscience and technology for aviation. Let's listen in to learn more. Okay. Hi, everyone, and thank you so much for joining us today. With me, I have Nam Nguyen. Thanks for making the time to speak with me.
Yeah, absolutely. Happy to be here.
Awesome. So to start, briefly tell us about your background. How has your career led you to iMotions?
Absolutely. So my background is in neuroscience. I initially did a lot of work in modeling behavior in decision making. And then that led me to a research managership over at Harvard, where I was the manager for a sleep and cognition laboratory under the direction of Dr. Robert Stickold. And I was with him for about 6 years. There, I executed a lot of different types of research looking at how sleep and memory interact, and I was lucky enough to publish a number of papers in that way. Mm-hmm. After I left Harvard, I went to defense contracting, where I did a number of sort of federal governments and efforts looking at things like fatigues in soldiers, maximizing individual aptitudes in TSA workers to soldier optimization and such like that. Oh. And then, 6 years ago, I joined iMotions, mm-hmm. where I am a consulting neuroscientist to help align some of the pre-sales efforts, as well as just kind of helping more complex post-sales integrations and efforts and technologies.
Nice. Super smart guy. We have had iMotions on the podcast a few times, but for those who are unfamiliar, can you just super briefly touch on iMotions offerings and maybe describe your role there a little bit more?
Absolutely. I like to think of iMotions kind of like a video editing software, except for biometric research. So everyone uses Final Cut as a way of taking video from any type of camera, mm-hmm. and turning that into a product. iMotions is kind of like that for biosensor research. We don't really care what camera you use or the tools that you use, but if you're interested in things like eye tracking, facial emotion detection, galvanic skin response, heart rate, and the various other things, we can take that data and help researchers turn that into outcomes. So record that all at the same time, edit it, and have an understanding of moment by moment what happened to human experience as it goes through. So.
Awesome. Very cool. So we recently published an ebook on the use of eye tracking in aviation use cases, specifically in human factors research, pilot monitoring, and training. I know you've mentioned in the past having conversations with pilots for years. Can you share more on that experience and what they maybe had to say about, eye tracking or otherwise?
Absolutely. So within iMotion's client base, we have a number of federal and commercial aviation clients. And for the number of years now, we've helped them execute a number of research efforts. And this can kind of go around a variety of different sort of domains. You can kind of think of it as two different main areas. One is training outcomes. So how can we optimize training, and how can we use these types of tools like attention, emotion, and various other sort of cognitive sensors in order to help optimize learning. The other one is to help with the sort of regulation of individuals. How can we, once they know the materials, can we use these types of tools to help sort of optimize the monitoring of pilots in the situation? So can we use things like eye tracking to help sort of monitor in-cabin behavior to help sort of optimize the way that they use, especially with the human-machine interactions that becomes more automated in the future.
Okay, so how do the sensor applications developed by iMotions specifically impact air traffic controllers and the pilots themselves, would you say?
So for the different sort of populations that aviation is interested in, whether it's air traffic controllers, pilots, or other individuals, if you look at it from first a training use case, the idea is that you want to be able to detect both the emotional, attention, and cognitive sort of effects when they're either learning, dealing with emergencies, or undergoing sort of any type of learning situation. And so you don't want a pilot, for example, to be technically able to land, but freaking out every time they do that.
Right.
And so being able to monitor the situation can help training programs optimize their teaching so that pilots and these other operators can learn as efficiently as possible. And when they go out in the field and they deal with unexpected situations, they're able to deal with emergencies in an efficient manner, so to speak.
Cool. Nice.
So things like heart rate, facial expressions, brain waves, skin conductance, skin sweat, all these things can give you insights into different ways that the human is responding to that situation. And so each one of those signals can give you various insights that might be very important to the coach or the trainer in that situation.
Okay. Cool. Now, how would you say that iMotions contributes to the aviation industry by outfitting, the Smart Eye Pro eye tracker? Could you provide an example or a proof of concept?
So one of the areas that we work with quite a lot is simulations. So a really important part of aviation technology typically is simulation training, which involves either something akin to what you might do on a computer with a joystick and or a PlayStation kind of thing to the very large $20 million, the entire front of an airplane that goes up and down inside an entire room moves. What we're able to do is then outfit it with something like various eye tracking solutions, such as the Smart Eye Pro, where you're able to then, moment by moment, understand where they're paying attention. So if a aviation cockpit is quite complex environment. There's a lot of screens, there's a lot of windows, there's a lot of buttons, and so understanding how much attention that they're sort of looking around. Are they able to navigate directly towards the area that they're supposed to, or are they confused? And searching their environment indicates a level of expertise and comfortableness they have with the procedures. And then once you layer on the other sort of tools, you understand things like cognitive workload and distraction and other ways that it might be impacted in terms of the different situations they might encounter.
Awesome. So in terms of flight safety, how valuable is it to convert, something like a Smart Eye Pro eye tracking data into the modeling of the head and the instrument focus during incidents of emergencies? I was curious how, this might improve efficiency and preventing errors.
So oftentimes when you're giving sort of training for safety and other things, it's a lot of learnings in the moment. So you can record events and then go back eventually and look at it, but it's much more powerful to be like, hey, just now your reaction was kind of not optimal for the situation. Instead of looking here and just flipping the button and switch, you seemed kind of confused. And then you're able to address almost with things like associative conditioning a little bit more natural. So you can actually train reflexes and have the more natural kind of I need to go here and not here. And by combining the type of sort of in the moment recordings, which you need a system like Smart Eye Pro where you're able to actually tell, okay, they're exactly where they're looking and when they're looking live, it helps them to optimize those types of conditions for safety.
Very cool. Can you explain the different levels of expertise and their impact on building performance metrics such as, tracking turns or altitude and scanning patterns and how iMotions might help on improving these metrics?
Mm. So yeah, a lot of training programs these days, they focus on the telemetry of, say, the airplane. So
Hmm.
a good pilot will, like under adverse conditions, be able to hold a plane within a certain approach. They won't, fall so far away from the runway. They'll be able to deal with the situation and keep the plane in an optimal location. But that's all on the telemetry of the plane. If you then add on to the things like, were they able to emotionally regulate along those situations, especially with, you can think of like human emotional responses as a filter between the decisions they make. So they might have a lot of book knowledge about what they're doing, but book knowledge to performance is filtered through human cognition and emotional state. So
Right.
if your training kind of prepares you to react to something, then you're less likely to make errors. You're more calm, cool. You're able to react towards things, especially with as much AI kind of aiding that happens
Right.
now.
Yeah.
It's very easy for pilots to rely overly too much on machines, and then you have things like what happens, unfortunately, to the situations where the AI crashes the airplane to the ground,
Yeah.
and their pilots don't quite take over. And so the optimization of maintaining an awareness and a situational awareness with the machine, I think really comes into play when you're looking at these types of systems that are able to maintain an understanding of both how the human is operating in the loop, as well as the way that the human is sort of being portrayed to the trainer.
Mhm. Oh, fascinating. So interesting. So, what is the significance of scanning in aviation tasks, and why is it important to quantify this skill? And again, how does iMotions assist in evaluating and improving scanning efficiency?
Oh yeah, so for it's a critical task that you can either fly by your instruments, so you can rely on what your instruments are telling you in terms of where things are in
Mhm.
space, but it is another critical task to look out your window sometimes and maintain like a visual sort of understanding of where certain things are, whether that's the approach of the runway, other airplanes that might be in
Mhm.
your airspace, things that might not necessarily be registered or informed to you by ground control, for
Yeah.
example. And so is really important. And they teach you to have a certain scan pattern, but they don't necessarily give you one golden rule. So everyone has
Okay.
necessarily their own approaches of, like, some people might do like a book reading from left to right, top to bottom. Other people might have other types of strategies
Mhm.
to maintain sort of an optimal way of like making sure that they cover their airspace and as
Yeah.
complete and efficient time as possible. And as you get experiences, just like with driving, you learn to pay attention to the things that are relevant and
Yeah.
not necessarily ignore them. And that tends to lower your workload. So
Mhm.
as you get more experience, you're not going to be as nervous there.
Mhm.
Um, Again, with the interaction uh, with these larger complex systems, whether that's ground control, whether that's more automation, whether that's more AI and more reliance on the machines comes into play. The
Mhm.
balance between looking at the window and to these other things will be really critical in terms of maintaining the maximum amount of safety or effectiveness
Mhm.
for pilot think in the future.
Got it. Okay. Cool. So, how does emotions incorporate, facial expression analysis? So, like Affectiva, we've worked together in the past, I know, and heart rate monitoring into their solutions. And how does this enhance traceability and contribute again to overall flight safety? Would you say?
Absolutely. So again, with emotional states sort of being the filter with that goes from book learning to performance, facial expressions and other metrics of sort of human emotional states kind of gives you an indication of things like, are they stressed, are they
Mhm.
distracted, do they have high workload? And so you can look at typically facial expressions, which if you have a trainer sitting next to you, they can't really see your face a
Mhm.
lot of the times. can give the trainer or the program some understanding of like, typically you're not going to be smiling necessarily. It's not something that's going to be there. But if you're frowning, if your brow is furrowed, if you're under heavier concentrations, it can be an indication of whether or not they're relaxed and they're under control, or if they're under some level of stress where they're trying to deal with the situation.
Okay.
Now, whether that stress is appropriate or not is going to be very context dependent on how they perform.
Yeah.
But it can give an indication to a trainer exactly like some idea of how far back, like things kind of fell off the rails, and then how to address different types of situations in terms of their training program.
Okay.
If you then layer on other types of sensors like heart rate or skin temperature, then you can get an understanding of things like, okay, how far, how deeply they're affected by that emotional sort of state. So facial expressions are great for indicating when and positivity, negativity. But if you then layer on other types of tools like those other things, then you can see a scalar, a magnitude effect between those other areas as well.
Okay, cool. So beyond the human machine interaction, right? So HMI, which you have touched on before, how does iMotions enable the knowledge and value of biometrics, eye tracking, attention, and emotion monitoring in aviation use cases? And can these measurements be addressed in real time?
So aviation, while it still is very important, interacting with a plane, there's also human-to-human interactions that occur quite a lot. It is a team sort of event, so interaction with your crew, interaction with the ground supports, all of which are important for like efficient sort of communication. So as you're approaching different airports, smooth linking up with their sort of personnel is critical in terms of like making sure that your airspace is clear, you're not going to run into other individuals. So you're heavily reliant on interpersonal communication, efficient interpersonal communication. And when those don't work very well, that's where you get things like close calls or collisions or landing on a runway that actually already has an airplane on it.
Yeah.
And so to avoid those types of things, you can utilize and leverage these types of systems to help smooth out these processes. So where are they confused? Where might the perception of the orders that occurs, the commands that come in over the radio might be kind of misinterpreted or not fully understood or garbled halfway through. So with communication, it's not just the sending of data, but it's also the receiving and interpretation of those signals. And so by leveraging things like EEG or how they are actually operating under like heavy workloads, you might then be able to understand a little bit more about like the likelihood of, say, mistakes happening.
Okay, cool. And one of the things that in our prior conversation we had talked about was the concept of summary scores and their role in debriefing sessions for flight safety. I was wondering if you could talk about how these scores are used in training and educational settings.
Absolutely. So with every sort of area, whether it's a surgeon, whether it's a military person, or whether it's a pilot, there's no golden standard necessarily about like what is stress, what is workload, what is distraction. So it's always context dependent, right? So what's stressful for a student, it might not necessarily, like in terms of their heart rate, saying like, oh, your heart rate is elevated, you might be stressed, might be very different in terms of the number that's stressed for airline pilots, which would be different for the stressed for like, ice cream server or something. And so when you create these programs, it's very difficult to create a golden rule there. So you do have to create they make their own rules. So you either create pilot studies where you're able to collect that data and you set a threshold where you're saying like, okay, well, this is what stressed or distracted or emotionally compromised is for this population group.
Oh, interesting.
So that you can tie it in and actually be effective in your diagnosis or your diagnostic between whether this person is compromised or behaving optimally in the situation.
Cool.
And so a summary score will kind of give you the ability then to make a judgment on whether they are. So what you're able to do is you're able to collect the database, get a single score, and then from that set your lines and thresholds for different sort of population groups. And that's always going to be something that, and in this case, something like AI or other things that we're working on right now could come into play in terms of making something that's reactive to different events.
Yeah.
So like, when you're assessing whether or not somebody is behaving optimally, so to speak, the situation, the population, their age, their gender, how many things are happening simultaneously can all kind of come into play, where they're saying like, well, just because their heart rate is elevated doesn't necessarily mean they're emotionally compromised in this situation. And so by having a summary metric, you're able to then average all that and distill it down to essentially a performance number. What goes into that number is going to be either rules or AI-driven sort of components that help kind of assess whether or not this number says you're compromised, you're performing optimally, or you're performing suboptimally.
Definitely. Yeah, context is huge.
Yeah.
So in terms of screening and education, what are the potential benefits and challenges of incorporating iMotions technology? How can they enhance learning outcomes and maybe reduce costs?
Well, because it's not out of the box, as just mentioned earlier,
Yeah.
then you do have to do an initial kind of testing, and you have to kind of create your own data set. A lot of people, they just want the number to represent high, low, medium performance right away. But in which we could do that, but it would be something that would be trained much more generally on general population groups. So we could predict, if you were a student or if you were a baseball player or if you were there, but it would be less accurate to the population group that you're looking to try to do. So that's kind of the main sort of barrier of this, is that you do have to still conduct some level of your own research in order to set where you believe the lines are for compromised and non-compromised. The other is there is the technology applications. So these technologies, while in aviation, there's huge costs kind of floating around. So you're oftentimes spending $20 million. So adding $100,000 of sensors might not be a big deal. But if you're on a desktop simulator and it only costs like $1,000, then it's a much different use case there. And the other is just general knowledge. So people that are pilots, they didn't go to school for eye tracking or heart rate tracking or physiology necessarily. And so understanding like where these might actually be a benefit to them is a bit of can be a bit of an obstacle. So to answer that, iMotions, as part of that and providing the technology, we also provide a lot of consultation and not a knowledge product. So whether that's, it's not just further reading, but it's like conversations with our in-house experts like myself, where we can help distill down saying like, well, heart rate is predictive, but only in these circumstances. Eye tracking is predictive, but only in these circumstances. But the combination of heart rate and eye tracking is more predictive in these better circumstances. And so what those are is going to be tailored sort of effort by effort. And so that's something that we'll have to continue to work at.
Awesome. Very cool. So taking it back to aviation, how does pilot monitoring evolve as automation becomes more prevalent in aviation? So what challenges arise? And I think you might have touched on a couple in maintaining human vigilance when machines handle a larger portion of flying tasks.
Well, absolutely. So, I mean, you touched on the main one is vigilance. So maintaining awareness and situational awareness when oftentimes you're not doing tasks for long periods of time. So the crux of how to maintain and measure vigilance is a difficult one. So just because your eyes are open and you're staring at the window, does that mean that you're aware that you're present there, or are you kind of a bit of a zombie and kind of thinking about your lunch overall? That's where like a combination of technologies like facial expressions is actually really good at understanding things like whether someone is kind of a zombie or they're sort of present. So if you're making any little movements, there's a great sort of measure called expressiveness or expressivity that allows you to just look at any combination of facial movements, and that oftentimes is a great indicator of whether someone is present or not. Or if oftentimes if you're just kind of zoned out, then your face just becomes slack and you haven't moved any muscles in quite a while. Versus any sort of facial movements there can be quite predictive of whether someone is here in the moment
Mhm.
and sort of understanding what's going on. Obviously, eye tracking, if you're looking at your monitors, if you're looking out the window versus just kind of like a 1,000-mile stare off into space, can be quite valuable there. And then other indications like skin response. So if you haven't had any sort of emotional responses in quite a while, maybe your skin's sweat will stay quite level, and that kind of indicates maybe they were quite bored in that situation. And so by looking at these again with a combination of different tools, you're able to then get better insight into how someone is behaving over long periods of inactivity.
Cool. So what are I don't know if you know a ton of this, but what are the current regulations and compliance systems in place that you know of today regarding pilot vigilance and automation? And how can iMotions technology assist in ensuring this pilot readiness and maybe intervention capability?
So today, I think it's still quite evolving very quickly.
Okay.
So I think the regulations are still catching up, and there's not quite a lot that's actually like in place right now.
Okay.
But I believe that they're coming. So especially again with these advancing kind of systems that will be automating quite a lot of things, it's going to be more important than ever to make sure that the human is behaving well in the loop, and kind of dealing with their sort of evolved role. And so by having these systems that kind of assist in the way that humans kind of interact with these machines, I think will be quite regulated in the future. And I think we're going to have to wait and see what's going to go on.
Definitely. So one thing I was hoping you could talk a little bit more about, we can't name them, but could you explain the iMotions collaboration with a large government organization in outfitting simulators and designing touchscreen interfaces? What were the goals and the outcomes of this project?
Absolutely. So, yeah, we are working with a number of government entities, and one of the main efforts is to streamline UI, essentially. So, what are the future of gauges, buttons, interactions with these systems going to look like? So, right now, if you can imagine a picture of a cockpit, there's a million switches, there's a million things. But as technology progresses and we move away from like the old interface to a new interface, what is that interface of the future going to look like?
Yeah.
So the designers of these technologies want to test and iterate very, very quickly. So instead of having like prototype switches that they have to print out and actually move things around, they're going to replace them with things like screens that are easily configurable. So like a UI designer can easily just go in and take that switch and move it somewhere else, or turn from a switch to a dial, or various other things. And so now it's a touch screen that's replacing a lot of the different areas.
Oh, okay.
And so when you do that, the question is, which sort of configuration is optimal? And so again, you can look at a combination of different sort of tools and technologies like eye tracking, facial expressions, galvanic skin response, EEG, to look at, what allows people to find a button the fastest. So if I ask, in this configuration, if I ask you to find the landing gear and the landing gear isn't in the same spot that you were trained on, how quickly is it for you to figure out as a trained pilot or a novice pilot or whatever to find that location, understand its function, and execute what you're going to do? In that way, like if you look at, say, the spaceships of the future, if you look at the ones that are there, they've replaced a lot of those buttons again with touchscreen interfaces.
Yeah.
By having all this real estate, it's very easy to come up with bad design. So you could be like, where is this button? Because it might not be on the screen at all. It might be hidden in a sub menu all of a sudden. And we've all kind of run into that. And when you're up in the air, you don't want to be searching through sub menus to find some critical function to put out the fire that's happening on your airplane. So
very like text while driving, reminiscent.
So a lot of research right now is going into optimizing interfaces with the systems there. So
awesome. Okay, so in the context of aviation, why is it important to maintain emotional composure and effective communication with air traffic control? And how can iMotions technologies contribute to achieving this balance?
With the idea of like maintaining the most safe environment, effective communication with your team is critical towards making sure that you are you have the most information available. So the ground kind of crew has all those tools available to them to communicate and direct the other entities within your space, whether that's other airplanes, things that are unexpected in the airspace, weather conditions, and those types of situations. By communicating effectively with them, a pilot is able to gain the most situational awareness with the operation. And so with tools like facial expression detection, heart rate, and other things that measure the human state, you're able to, in a sense, understand the effectiveness of these communication tools and events. So whether that's you're being overloaded with too many commands and you're confused of the source of like who asked me to do what and where.
Yeah.
By having these types of recordings and other sort of events, you're able to help one, either optimize the systems so that they're less confusing, or two, optimize the trainings for the individual so they're better able to mentally parse out what they need to know and ignore things that they don't need to know.
Awesome. I was hoping you could clarify the primary role of iMotions in the aviation industry. How does it contribute to research and development in this field?
So iMotions as a whole, our mission is to lower the barrier for integrating biodata into research efforts. And so in the aviation industry, most of the people interested in training are pilots or ex-pilots or program managers, and they're not biometric experts there. So what we do is we make it easy to then integrate tools like eye tracking from devices like Smart Eye Pro, or other types of tools with things like heart rate, skin sweat, facial emotion detection from engines like Affectiva, to other types of things like brain responses, in order to have them record it, interpret it, and then be able to apply those types of insights to the questions they have, like pilot training, pilot proficiency, where along the journey they have for different levels of proficiency that they might actually have. So.
Awesome. Perfect. So could you explain how biosensors and eye tracking technologies are currently being utilized in the aviation research?
So primarily right now, most people are starting off with eye tracking. So using those types of tools like simulator-based, screen-based, or glasses to look at devices in cockpit to understand attention. So by using a tool like Smart Eye Pro, you're getting that live data on different screens, different panels, the windshield and such. And so in training sequences, you're able to do things like ask questions about what they're paying attention to in the moment and give them direct feedback with that type of information. In training scenarios, then that becomes relevant towards things like, if you have a particular event happen, did they pay attention to the correct areas? Are they searching? Do they seem confused with their search pattern? And so they're able to do that. And these are the current sort of main use cases. Other tools that are being leveraged right now are just kind of exploratory, more along the lines of things like emotion regulation. So heart rate, facial expressions are being used, but they are quite the frontier.
Nice. Perfect. Do you have any specific insights gained from working with pilots using these technologies?
Specifically with pilots and trainers together, they like being able to understand sort of a deeper truth about what the pilots are sort of experiencing moment by moment. So as people, we're good at sort of remembering what we did, but we're not really good at remembering why we do it or the pattern and order that we do things in. So we suffer from a variety of things of like biases, like recency bias, so that we understand what we did last, but it's harder to remember the middle process for what happened there. And so, you might understand if you performed a task, but did you efficiently look at step 2, step 3, and step 4 in the correct order? That's not something that we're built to sort of memorize. So trainers are like it so that they're able to record those types of interactions, saying like execute a particular procedure, such an approach. You're supposed to do these particular steps, hit these switches, check these screens. And in doing so, by having a recording of that, you're able to better understand the whole process and even show people things that they might not themselves realize in the moment. So,
perfect. Okay, cool. So I know it's important to distinguish between research and operational pilot training. I was wondering if you could elaborate on how the technologies you've mentioned are primarily geared towards research purposes.
Absolutely. So with research, you're developing the insights and understandings from data. So in order to create something that actually applies towards in the moment pilot training, you have to understand like what is normal and what is outside of norms. To develop that norm data set, you have to do the research in order to find out, okay, well, what is the heart rate? What is the search pattern? What is the amount of things that differentiates questions like a novice to someone that's proficient, or someone that might be, someone that you could pass that test for example. And to answer those questions, like you don't know what the heart rate of someone that is proficient is ahead of time. You don't know,
Yeah.
What is the normal amount of search that should be done for a population group, and especially if you change the parameters of the experiment to different hardware or different models of tools. So, for example, if you go from a small airplane to a larger airplane, what is the difference now that you have to look further around and you have much more sort of instrumentation to deal with? And so, research then deals primarily with developing those data sets so that they can come up with the final norms that then get applied towards the everyday pilot training, so that when they just look at A, B, and C indicators, they can say, oh, that person is within normal performance, or they're performing outside of expected ranges. And so that's kind of the difference between R&D and training.
Okay, perfect. So, what are the potential challenges or barriers to implementing these technologies in operational pilot training, if there are any that you know of?
Typically, it's the main barrier is adoption and knowledge. So eye tracking itself is kind of a new technology for the majority of these pilots. Just sitting there next to the person and trying to get a feel, either through sort of a gut feeling or direct observation of what they're looking at in that moment in time, has been the norm. Uh, Adding in these new technologies, understanding how to use them, the additional button presses, the amount of time and effort it takes to integrate these tools is effortful, and needs to be sort of traded by the benefits that they get on the back end. So and then that then compounds with these other types of things like emotion detection or glow detection or stress detection through various other signals. And so it can be a compounding amount of knowledge and work to get these other signals in. And that's why something like iMotions, which lowers the barrier of entry by getting it all on one screen and providing support for signal interpretation, comes into play, where we're able to say, okay, well, in the moment, when situations happen, looking at not just where they looked, but how they responded and how much they responded on one screen, kind of bridges the gap between expertise and interpretation.
Awesome. So I think in prior conversations, you may have mentioned that wearing a certain biosensor gear may not be allowed in commercial pilot training for certification reasons. I was wondering if you could provide more details on that and why that might be the case.
I mean, obviously, you want the pilot to be as naturalistic to the cockpit as you can,
Yes.
and this applies towards military as well as commercial airline industries. But you have things like for the military space, helmets, and helmets get in the way of seeing the face and seeing the locations of these placements. In actual airlines, I mean, there's a reason why they tell us to turn off their cell phones, because these signals don't want to be transmitted all around. And obviously, use in an actual airplane will get limited by actually having the systems in that device. And that's where R&D simulations come into play, where you're able to have a large PC in the background that's dedicated to just collecting that data there. Can you get technologies that are laptop based or more portable? Absolutely. But you're also looking at the duration of recording. So if you're looking at, say, video data is quite data intensive if you're recording at high resolutions. And if you're on a 2-hour, 3-hour, 4-hour flight, you're now looking at terabytes worth of data to analyze, and that can become quite an intensive analytic sort of pull for not just the system, but then for any analyst looking to try to pull things from that 4-hour flight and understand what went on there. So bridging the gap from field to from lab to field is got a variety of different challenges there, obviously, and those will need to be addressed through these developmental efforts that are partnered with, say, these companies, tools, and airplane makers as well.
So what do you see as the timeline or the potential steps for these technologies to transition from research to operational training, if ever?
I mean, we're seeing it happen already in terms
Okay.
of a variety of different industries that are integrating in our systems into their research pipelines, and so they're looking to find those norms and normative databases to create these products so that they can simply throw on a meter to a pilot and say, you know, your pilot is performing within expected parameters of attention, vigilance, and a variety of other sort of areas.
Mhm.
Will those appear in the cockpit? Absolutely. When will they appear? It's kind of hard to predict exactly, but I'd be surprised if these from a training standpoint are already in play or already coming online momentarily. And then in terms of the actual fieldable systems that appear in the 747s, in the next few years, you should see it popping up there as well.
Okay, the last question I had for you was, what do you envision as the future potential for biosensors and eye tracking technologies in the aviation industry? So both in terms of research and operational applications.
Our types of tools and technologies, whether it's getting eye trackers, emotion regulation kind of tools, workload regulation, distraction regulations, all of these things, when you look at the evolving sort of process of flight training and flight operation, is going to be massively important. So whether it's optimizing training programs to interact with the smarter and smarter technologies or more automated tools and cockpits in the future to the actual operation themselves, I think looking at the human in the loop, so to speak, is going to be always very, very important. So I think our tools and technologies will contribute massively towards optimizing and getting these pilots trained as quickly as possible. And then in the back end, when they're actually out in the air, being able to apply these types of tools and technologies into like systems that actually help monitor and interact with the individuals, so that, you know, if the plane say, knew when the pilot was incapacitated or panicking or in a state where, like, you know, maybe I should understand why the human in the can is doing a certain thing. I think those types of tools and technologies will be very, very valuable, so that, you know, the man and machine can work together in the future in a more integrated way. So.
Perfect. Okay, so we've covered a lot of ground today. If you had one takeaway for the audience listening, what would you like to tell them based on everything we've talked about?
Biosensor technology is more approachable than ever today. You don't necessarily need a PhD in understanding things like signal processing from brain waves or eye tracking and such like that to understand that with these tools, it's easy to understand how people respond, what they're responding to, and how much they're responding, and the value that gives towards efforts in training as well as monitoring performance.
Perfect. All right. So for our listeners, can you let them know where they can go to learn more? Or do you have any other call to action for them?
You can go to our website at www.imotions.com and go to our website.
Awesome. Great. Well, that's all I had for you, Nam. It has been a pleasure. And thank you once again for taking the time to have this fascinating deep dive conversation with me today.
Thank you.
I enjoyed speaking with Nam about how biosensors and eye tracking can be deployed for pilot training and ultimately can enhance flight safety. He really made a great deal of the more tech scenarios and ways in which the tech can be applied to aid the aviation industry. I hope you enjoyed today's episode. Don't forget to subscribe to the Human Centric AI podcast on iTunes, Google Play, Stitcher, or wherever you get your podcasts for new episodes. We are also on social media, so please reach out to us on Twitter, Facebook, LinkedIn, and Instagram to share any feedback you have on the show and weigh in on the discussion using hashtag Human-Centric AI Podcast. Don't forget to rate us and comment with your feedback to help make the podcast more discoverable for others. Until next time, thanks for listening.